Let's take a look at a few more linear equation examples. Let's say we have 4y minus 3 minus y equals 2 times the quantity y plus 1 minus 1. So in this video, I'm going to assume we're already comfortable with how to solve a linear equation. If for some reason you haven't covered that yet, you might want to stop this video and go back and watch our video on how to solve a linear equation. All right, but in any case, if we do know how to solve them, let's proceed. The step one is always to simplify both sides before you begin. That includes doing things like combining like terms, like the 4y and the minus y. Also includes things like distributing this 2 out. So let's do those things first. 4y minus y would give us 3y. And we'll have minus 3 equals, and then we'll distribute the 2. We'd have 2y plus 2 minus 1. Then I see that we've got a plus 2 and a minus 1. We can combine those. So we'll have 2y plus 1 on the right side, plus 2 minus 1 gives us 1, equals 3y minus 3 on the left-hand side. So step one's done. We've simplified both sides. The next step is to move the variables to one side of the equation and the constants to the opposite side of the equation. So the way we can do that using correct algebra is to add or subtract to move these terms around. You can move the 2y and subtract it away and translate it to the left-hand side, or we can subtract 3y and move it to the right. I think it'd be smarter to subtract 2y from both sides. And the reason I think that is because then when you have 3y minus 2y, it would leave you with just a positive y. If you move subtracted the 3y to the right, you get a negative y. There's nothing wrong with that. It's just preferable to leave a positive coefficient, if you can easily. Then we still have minus 3 equals, and there's still a 1 on the right hand side as well. So the variables are on the left now. Now it's time to move the constants to the right by adding 3. And just keep in mind, you always have to do the opposite operation of whatever's done to move it off of that side. So if you have minus 3, the only way to get rid of the minus 3 is to increase that side by 3, and that'll make these cancel. But to maintain the equality, if you increase the left side by 3, you also have to increase the right side by 3 so that the equality is maintained. And then we get y equals 4. And normally there's an additional step where you divide by the variable's coefficient, but this is kind of a unique example where the variable doesn't have a coefficient. If it was 2y equals 4, we'd divide by 2 or something like that. But we just have y equals 4, so we're done. There's nothing else to do. I'm not going to take the time to do it, but you're welcome to. We could verify that this is really the solution to this equation by going back up to the original equation and plugging 4 in for every y that we see, and then just asking the question, does the left side really in fact equal the right side? And I think it will. You can check me on my algebra, but if it comes out as a true statement, then 100% we've got the right answer. Okay, here's our second example. Negative x over 2 plus 5/6 equals 1/3. Now, definitely the thing that jumps out to me with this problem is the presence of all the fractions. And students, in every algebra class in every school, they always are real hesitant about fractions. And so the best thing you can do is, if you remember a tip we made in an earlier video, is you can get rid of the fractions before you ever begin by multiplying both sides, the left side and the right side, by the least common multiple of all the denominators. So you have a denominator of 2 and 6 and 3. So we need the LCM of those numbers. And we made a video earlier on how to find least common multiples. A good way that works the majority of the time is to start with the biggest number and to write down just a few multiples of the largest number, like 6, 12, 18, etc. And then start with the lowest number and see if it's a multiple of everybody. And if it is, you've got your least common multiple. And if it's not, then you mark it out and then you go to the next one. And you should find it in relatively little time. So let's start with 6. 6 is a multiple of 2, so that's good. 6 is obviously a multiple of 6. And 6 is a multiple of 3. So actually we find this one very quickly. So the LCM for this problem for these denominators is going to be 6. We'll multiply 6 by the left-hand side and the right-hand side. And somehow that should help us. Let's see how the algebra plays out. When you distribute the 6 on the left-hand side, part of what you have is a 6 divided by 2. And 6 over 2 gives us 3. We'd still have negative x, so we'll have negative 3x. That's 3 times negative 1 times x, and when you reorder the terms, you can write it as negative 3x. Distribute 6 to 5 divided by 6. The 6's cancel, and you just get plus 5. Equals, and then you'd have 1/3 times 6, and 1/3 times 6, or 6 divided by 3, is 2. So you get an equivalent equation, and what's preferable about this yellow equation is it does not have any more fractions. And so again, just to reiterate, the reason multiplying by the LCM of all these denominators, the reason that works is because 6 is a multiple of 2 and 6 and 3, all of these fractions, 6 over 2, 6 over 6, and 6 over 3, they're all going to cancel that denominator away. And in your resulting equation, you won't have any fractions, and that's great news. And so once you get here, then it's pretty downhill from there. You isolate the variable term. You put the variable on one side and the constants on the other. So we'll subtract 5 from both sides. So we'll get negative 3x. These cancel and equals 2 minus 5, which is negative 3. We'll divide by the variable's coefficient of negative 3. And final answer, x equals 1. Okay, again, same as the last one, I'm not going to go back and check this, but you're welcome to. You can take 1 and plug it in for x, and it should make the original equation be true.